Why not current electricity?
Yeah.
Why not current electricity? I am saying.
Uh, any chapter is fine. Current electricity we have just started.
Where you have started that?
We're in the starting, right? Um,
So should I start from current electricity as we have to complete the syllabus till November? So uh,
yeah,
we will
you can
cover
start.
that. Okay, that's fine. First, listen me. So we will cover that electrostatics part. Okay, or later. Okay. So please
Okay.
listen each and every word carefully. Okay, and okay now current electricity. Okay. So first thing is uh, what is current? Okay. The first question is what is current? And current is the rate of flow of charge. Current is the rate of flow of charge. It means here is a charge plus Q, and this charge is at rest. This charge is at rest. So no current will be generated. No current will be generated. And this thing we have studied in the electrostatic. So forget this thing. So we will discuss here only the moving charges. Okay, moving charges. So electric current. Electric, electric current is the rate of flow of charge. Rate of flow of charge. Okay. So you can say that if there is a charge and this charge is in motion, charge is in motion. This charge generates the electric current. Okay, this charge will generate electric current. Electric. So now this is the basic definition of electric current and how the electric current is produced. Electric current is produced due to the motion of charge, whether it will be negative charge or it will be a positive charge. That's okay.
Yes,
So
sir.
see here, this is the wire. This is a wire now. Wire. And in wire, the current is flowing. In this wire, the current is flowing. So why I am telling this? And wires are the conductors. That is why the current flows in those wires. Wires are the conductors. Suppose I am taking a cylindrical conductor, or you can say this is a cylindrical wire. Cylindrical conductor, or you can say wire. Okay. And this is the cross section area. Cross section area of this wire. Okay. This is the cross section area. I am representing cross section area with A. Cross section area with A. A is the cross section area. And this is the cross section area. And from this cross section area, some charge delta Q. Do you know delta? Have you heard about the term delta? Delta means change.
Yes, sir.
Okay,
Change,
change.
right?
So I am taking here this. I am taking here this delta Q charge is flowing through this conductor, and this charge is flowing for the time of delta t. For the time of delta t. Delta t is time. For example, suppose this is a conductor, and in this conductor the 5 coulomb charge is flowing from here to here, and we can take a time like for 5 seconds and for 3 seconds. Okay, you can understand this. Okay, so if I want to calculate the electric current in this conductor, then I can take hello.
Hello, sir.
Hello. Actually, I have lost my connection
Yes,
once
sir.
again. So
Internet
sorry for
issues, right?
that.
No problem,
Yeah.
sir. It happens.
Okay. Okay. And now I'm sharing my screen again. So we were talking about the electric current. So electric current is represented by this capital I. Okay. And if I write the formula for electric current, so simply you can say electric current I is equal to charge flowing, and for what time the charge is flowing means delta Q by delta T. Okay.
Change.
Yeah. Or sometimes you can simply write this as Q by T. Okay. Sometimes. And this current, and one thing I want to clear here, uh, in 11th class, we have velocities. Like we have average velocities and instantaneous velocities. So average velocities means for a certain period of time. When we measure the velocity, for a certain period of time, that is average velocity. And for an instant of time, the velocity is instantaneous velocity. Like you can say there is a person and this is moving like this. This is the time he or she has started at t equal to 0, t equal to 1 second, t equal to 2 seconds, okay, and t is equal to 3 seconds. He or she is moving along this path, t equal to 4 seconds. Means at t equal to 1 second he is here. After that he is here. After that he is here. After that he or she is here. If someone is saying velocity between t equal to 1 to t equal to 4, so it means t equal to 1 to t equal to 4, this is a range of time. So means they are asking the average velocity. Okay, they are asking the average velocity. And if someone says that calculate the velocity at t equal to 2, calculate the velocity at t equal to 2, means this is instantaneous velocity. So that's how we can recognize this. Instantaneous means at a point of time, at a point of time. And okay, so and one thing more, do you know vectors?
Yeah, class 11. Somewhat I
Yeah,
remember.
okay, no problem. So vectors are the physical quantities which have magnitude as well as direction. Like you can say force. We apply force with some direction. Like I am applying a force in north direction, like this. I am applying a force in this direction, like in this direction. And charge. Charge is a scalar quantity. There is no sense of direction in charge. Means I am saying that 5 coulomb of charge. So there is a charge, only magnitude, no direction. So current is a scalar quantity, electric current. So it is scalar, okay, scalar quantity, and SI unit is ampere. SI unit is ampere. Like SI unit of force is Newton. In the same way, the SI unit of current is ampere. So, so if I want to calculate the average current, IAV means average current. Average current. So the average current will always be delta QY, delta T, and if someone is asking instantaneous current, instantaneous current. So I am representing instantaneous current as INS, suffix INS. And instead of this delta, we will write D, QY dt. You can compare this with the velocity also. Like in case of velocity or speed, if we calculate the instantaneous speed, so instantaneous speed is distance ds by dt in 11th class. And if we calculate the average velocity, then we write delta s by delta t. So, so it means nothing has changed from 11 to 12. Only the terms are changed. So, this is the average current and this is the instantaneous current. Have you written this?
Yes, sir.
Okay, good. Now there is a point. Uh, listen, means this is a wire. This is a wire, part of wire, and current is flowing from here to here like this. Okay. So current have a direction. Current have a direction. Now we will discuss about this direction. So direction of current is same as that of motion of positive charge. We know that there are two types of charges. There are two types of charges in this world. One is positive charge, another is negative charge. Okay, one is positive charge, another is negative charge. And suppose if positive charge is moving, this positive charge is moving in this direction. Okay, so direction of current will also be in this direction. Direction of current will also be in this direction. So I am writing here direction of current will also be in this direction. Okay, now if negative charge is moving, negative charge can also move. If positive charge can move, then negative charge can also move. If the negative charge is moving in this direction, then the direction of current will be opposite to this charge. Direction of current will be opposite to this charge. So this charge is moving in this direction. So the direction of current should be in this direction. This is I. I is current. I will represent current with I, capital I. Okay. So have you written this?
Yes, sir.
Okay, good. So mean simply current is the listen here. Current is simply the charge divided by time. Okay, and the direction of current is same as that of positive charge. Okay, and direction of current is opposite to the direction of motion of negative charge. Okay, you have to remember this. Now, graph of charge versus time. You know, there are graphs. Graphs. Do
Yes,
you
sir.
know about graphs?
Yes, sir.
Okay. Charge versus time. We know that current is equal to charge upon time, and if I calculate Q from here, Q will become I into T, and in 11th class, do you have mathematics or biology
Biology.
in your? Okay, so I have to tell you then. So we have, if this is y-axis and this is x-axis. This is x-axis. And if the graph is like this, means if a line is passing from origin, this is origin. The line is passing from the origin like this. So we write the equation of this line as y is equal to m into x, and m is equal to slope of this line. Okay, slope of this line. And if this line makes an angle theta with the x-axis, then also we can write tan theta is the slope. Okay. So now you can compare this from here. You can compare this. You can compare. If I am taking charge on y-axis, if I am taking the charge on y-axis, I am just comparing, and this will be m for slope, and this will be time. This will be time. Now, if charge is on y-axis, q is charge. Charge is on y-axis and time t. I am representing time with small t. Time is on x-axis, and according to this equation, the graph of this will be like this. Straight line passing from the origin. Straight line passing from the origin. Straight line passing from the origin. Okay. 4 times T1, the charge will be Q1. 4 times T2, the charge will be Q2 simply. Okay. So if I want to calculate the slope of this graph, if I want to calculate the slope of this graph, slope of uh, Q versus T graph. Okay. So I can write slope equal to, if this is making angle theta, tan theta, and I can also write this as, I can also write this as charge upon time. Charge upon time. And what is charge upon time? Charge upon time is current. Charge upon time is current. Why I have written the charge upon time? Suppose, please listen first, and after that you should write. Okay? This is charge and this is time. I have written slope equal to tan theta, that is equal to qyt, and that is equal to current. If I want to calculate the slope of this graph, if I want to calculate the slope of this graph, suppose this is the value, some q value of charge at some time t. Okay, at some time t, and this is the angle theta, and we know that slope is equal to tan theta. Slope is equal to tan theta. Okay, and tan theta, if I want to calculate the tan theta from the trigonometry of 10th class, tan theta
Sine
is
upon cos.
sine upon cos. That is fine. But I can also write this as perpendicular. If I am talking about the triangle, then I can write this perpendicular upon base. So in this triangle, see, in this triangle, hmm, in this triangle, this angle will be 90 degrees. So this is perpendicular. Okay, P is perpendicular, and this is base. So perpendicular is this, and base is this, and here is origin. So the length of this P and B, perpendicular divided by base. So perpendicular is this distance. This distance is Q, like from here to here. Q, and this is base, and base is the distance T. This is the T distance. So that is why I have written this, and this is equal to I. I is equal to Q by T. We have already discussed. Okay. So please note it down. You have completed till here. You have completed
Yes, sir. Yes.
this all. This
Yes,
graph
sir.
also completed.
Yes, sir. I want the down graph.
Okay. Okay. Now you are writing this.
Yes.
Fine.
Yes, I finished.
Good. Actually, you are very fast in writing. So there is one more graph. There is one more graph. Earlier we have drawn the charge versus time graph. Now I am drawing the current versus time graph. This is y-axis. If current is on y-axis and time is on x-axis, this horizontal line represents the x-axis, and this vertical line represents the y-axis. And on this y-axis there is current, and on z-axis time is there. And if I draw, you can think like, if the graph is like this, so if the graph is like this, so the area of this will give us the charge. area of this. This is the triangle. This is the triangle, no? So, okay, fine. So we know that I into T, I into T is equal to Q. We have written Q is equal to I is equal to Q by T. So from here I can write Q is equal to IT. So I have written this here. I is IT equal to Q. So from this we can say actually this is the part of integration. This is a part of integration, but you simply calculate the area of this triangle, you will get your answer. So area under I is current versus okay T is time graph okay, gives charge Q. Charge and charge is represented by Q. So if we will calculate this area means we will find the value of charge. We find the value of charge. Okay. Beta, what is your name?
Sir, Emberely,
Emily. You are from where?
Goa.
Right now you are in Goa.
No, sir, I'm in Oman. I study in Oman.
Okay, that is fine. Completed?
No, sir, I'm writing.
Okay. Take your time in writing. Okay. Don't try to be fast. And first listen and after listening, write.
Yes, sir.
Okay. You should know these things, how to calculate the slope, how to calculate the area. Okay. These things are required in physics. We cannot simply do what is current is charge flowing per unit time like this. We used to have to solve the numerical also. And for that, we should know all these things.
Sir, can you help with integration?
Of course. Do you know differentiation?
Yes, sir,
Okay. Oh,
differentiation. I'm thorough with differentiation, but with integration, I face
okay, okay,
difficulties.
okay, okay. So I am checking whether you know about the integrating y equal to x square. You don't know that is that's not a problem. I can teach you. Okay, now my internet connection is okay, so I can connect it with my net. Okay, wait a minute. Hello.
Hello, sir.
Actually, I have lost my connection that time, and we will start again. Okay.
Okay, sir.
Okay. So current is, what is current
Rate of flow of charges.
in terms of formula? Charge divided by
Q
time.
by T.
Q by T. Very good. Okay. Now let's start. So now it's okay. Okay.
Yes, sir.
So we were talking about. Can you tell me what is the differentiation dy by dx of this
2x.
x? Oh,
2x.
very good. Very good. 2x. Okay. I I don't know what is happening today.
Sir, you can try switching off your video. It
No,
might help.
I don't think so. Actually, it's a problem of system. So this is 2x. This is 2x. Okay.
Yes, sir.
So now if I am asking what is the, if I am writing y is equal to 5x cube. What is dy by dx?
15x square.
Very good. If I am asking dy by dx of, oh sorry, y is e to the power x. What is dy by dx?
1 by EX.
Yeah, 1 by ax. But I actually, you should remember this thing. If
Yes,
we
sir.
differentiate the exponential function e to the power x, then this function will remain same. Okay, this function will not change. And we will talk about the integration later. Okay,
Okay, sir.
so don't worry. Means I think you know the sufficient differentiation. So now I can continue. So okay. Now this is the theory part. This was the theory part, and now the questions. Question is charge flowing through a conductor. Do you know what are conductors?
Yes, sir. They help in the flow of current.
Yeah. Anything else about the conductors?
Mostly metals.
Yeah, you are right. And the main thing in the when we call the material conductor means they have free electrons. Okay. So we have to calculate current in 0 to 2 seconds as for seconds, and current at t is equal to 2 seconds. So charge is flowing like this. Charge is flowing like this means this is time. T is time here. T is time here. Okay. Charge is flowing like this in a conductor means charge is varying with time. As the time changes, the charge will change in a conductor. And so please listen this carefully. We have to calculate current in 0 to 2 second means we have to calculate the average current. I have told you na in the beginning
Yes, sir. Average current.
average current. Why average current? Because this is a time range. This is the time range, not the point of time. So for I average, we have delta Q by delta D. Okay. So I can write it as charge means this is the initial stage and this is the final stage. At t equal to 0, I am taking the initial stage, and at t is equal to 2 seconds, I am taking. So I can write here delta Q means change in charge in that time. So I can write charge at t is equal to 2 minus charge at t is equal to 0 divided by T2 minus T1 means I can write here T2 minus T1, and you can write in your own way also. That is not a problem. So when you calculate this charge at T is equal to 2, charge at T is equal to 2 means put the value of T here. T is equal to 2. Now I am substituting T is equal to 2. So this will become 3 into 2 square. I am putting the value of T in this equation. Why? Because this is the charge at T is equal to 2 plus 2 T is 2 plus 1. Okay. And now put the value 0. We will put 0. This will become 0. Okay. When we multiply 3 with 0, this will become 0. Plus this will also become 0 because T is 0 here. Only thing is here is 1. And T2 means final, you can say. This is 2 minus 0. And we will get the answer. Can you calculate the answer for me?
Yes, I'll try.
Okay. And you should check your answer also. What is the answer?
8 ampere.
Yeah, 8 ampere. Another question is current at T is equal to 2 seconds. At.
Instantaneous.
Yeah, very good. So means they are asking instantaneous current, and for instantaneous current we will use the dq by dt, and that is differentiation. That is differentiation of charge. You will
Yes.
differentiate this charge with respect to time at t is equal to 2 seconds, and you will get the instantaneous current. So this will be dq by dt at t is equal to 2 seconds. So now please differentiate this. This will become this 3t square plus 2t plus 1. Are you comfortable with this?
Yes, sir.
And you should put the value here, t equal to 2. So this will become 6t plus 2, or now put the value 2. 6 into 2 plus 2. This will become 14 ampere. A is for ampere.
Yes, sir.
So these kinds of questions from this current you will get in your examination also. Have you understood what I am saying? Means what is average current, what is instantaneous current, how we will calculate the instantaneous current, how we will calculate the average current.
Yes, I understood.
There is one more question. You know electron?
Yes, sir.
Okay. An electron revolves around the nucleus. You know nucleus?
Yes.
Okay, good. With frequency. Do you know frequency?
Yes, sir.
What is frequency?
Uh, V is equal to 1 by 2.
Very good. Calculate the current generated by electron. So in the beginning of the class, I have told you if a charged particle will move, when the charged particle will perform motion, the current will be generated, and here is electron is moving and electron is having a charge, means electron is a charged particle, and that charged particle is moving, means the current will generate, and that current we have to calculate. So no problem. You should know what is happening inside the atom. At the center there is nucleus,
Yes.
and okay, there is nucleus, and electron revolves around the nucleus in the orbits. This electron will revolve like this, like this, with some velocity, you can say. And we know that there's a term called time period. Time period means for completing the one round, the time taken by electron is time period. Now, and we know that current is equal to charge divided by time, charge divided by time. And charge on electron we know 1.6
1.6
into
into 10
10 to
raised
the
to
power
minus
minus
19.
19 coulomb. And now I am representing charge on electron as E. Okay. I am just calculating the magnitude. You can write this charge as minus E also, because charge on proton is also E. Same charge is on proton 1.6 into 10 and minus 19. And what about the time? we have known here only the time period. So we will put the value of time period now. Time period in completing means from here the electron will revolve like this, like this, like this, like this, and complete one revolution. Then it will take a time t. T is the time period. And you have told me that frequency is 1 upon time period. So minus E. Instead of 1 by T, I can write F. So the value of current is minus EF. If someone is asking us only magnitude, so we can write I is equal to EF. So what is happening here? Here the electron is revolving around the nucleus, and electron is a charged particle. And whenever a charged particle is in motion, the current is generated. Same is the case for proton, but proton is inside the nucleus. We know that proton is inside the nucleus. Protons and
Neutrons.
yeah, neutrons. These arrow represents the velocity. Okay, so
So for magnitude, we have to not take minus sign, right?
yeah. Now there is a question. Without the mathematics, you cannot understand physics. So you should know how to calculate the areas, how to differentiate a function. Not in detail, but you should know the basics of mathematics. So here is a question, and things like this. Mhm. This is the y-axis. Means this is the y-axis means on the y-axis this time is current,
Yes.
and on the x-axis t is the time. So this graph is given as question. So here the value of current is 10 ampere. A is for ampere. And this is a time axis, means on this axis we will get the values of time. Means here t is equal to 0. Here t is equal to 0. This is origin, you can say. T is equal to 0. Here t is equal to 5. T is equal to 5. And here is t is equal to 10, and time is given in seconds. S is for seconds, and current is given in ampere. This is the graph. Fine. And the value of current in the negative current axis is given as Here the current is 5 ampere, minus 5 ampere. Okay, fine. This is the graph. Okay. Now we have to calculate number one, charge in 10 seconds. Each and every word of the question is important. Charge in 10 seconds. 10 seconds. Means in 10 seconds means from 0 to 10 seconds means there is a time range. So we will calculate the average current now. Average charge, or you can say average current.
Average.
So average charge delta Q, we will calculate the value of delta Q. And now they are saying average current, calculate average current in 10 seconds. 10 seconds. Okay. Now what we will do? I have told you, if graph of I versus T is given, here you can see
Area under
the area under the time axis of this graph will give you the charge, total charge. Okay, fine. So now let's see. And we know that charge is a scalar quantity. Charge is a scalar quantity. So we will take charge with sign. Means the meaning of this is that if I calculate this area, and this is in the positive time axis, and this current, okay, under this, okay, and if I calculate this area, so from this area I will get a charge, and from this area also I will get a charge, but from here I will get the amount of negative charge, and from here I will get the amount of positive from here I will get the amount of positive charge, from here I will get the amount of negative charge, because this is negative. Yeah, so you should remember this. So now we will calculate this area. I am representing this area A1 and this is area 2, and this area gives us the charge, and this area gives us the charge, and this total area A1 plus A2 gives us the total charge. That, okay. So total charge is delta Q is given by A1 plus A2. I am writing plus, no problem, we will calculate the area. So delta Q is equal to, what is A1? This is the triangle. This is the triangle, and area of triangle is given by
half
half. Very good. Base into height, and value of base is from t equal to 0 to t equal to 5, means the base is given as 5. Okay, and height is given as 10. Half 5 into 10. This is half into 5 into 10. This is plus now. Now we will calculate this area. This is half, and this is, what is the value of this base? 5. 5. Very good. 5. And what is the value of this minus 5? We will take the sign minus 5. Okay. So from here we can calculate this. This will become 25 minus 25 by 2, and we will get the answer 25 by 2.
Yes.
25 by 2, we will get the answer, and that is, you can say 12.5 also ampere.
Coulomb.
Oh, sorry, coulomb. 12.5 coulomb. Okay, no problem. Now we will calculate the average current. Average current. So average current is delta Q by delta T,
Yes.
and we know the value of delta Q,
Yes.
12.5. And what is the delta T? Delta T is 10,
10.
because from here the charge started flowing, and from here to here we have to calculate the value of charge or current. So delta T is from t equal to 0 to t equal to 10 seconds. So 10 minus 0 means 10. You can write here 10 minus 0. So this will become 12.5 divided by 10, and the answer is 1.25. And this time this will be ampere. Is it fine? Okay. So these kinds of questions you can get in your examination. Okay. And suppose if I am asking, if y is given as 3e to the power, sorry, this is y is given as 3e to the power x. And now, can you calculate this? You should try this.
1 divided by 3ex.
No, no, no. You should listen first. You should listen first. Actually, I have told you, if you differentiate e to the power x,
Yeah, it will be the same.
it will be the same. And this is the constant now.
Yeah, so
So
it's
in listen. So 3 is constant. This will be like dy by dx, and we have to differentiate this 3 e to the power x. Okay. These things are very important. Why? Because the I know the medical students will get difficulty in these things, all these things only. They can relate with the theory and all that, but when mathematics come, you know that. So this is 3. 3 will be outside because 3 is constant, and constant is always outside the differentiation or integration. Okay, we will see
okay,
that.
sir.
So now we have to differentiate this, and I have already told you the differentiation of this is same,
Ex. Yeah.
ex. So now tell me, what is the differentiation of 1.25 e to the power x?
Okay, sir.
Right, you can easily tell, na, this will remain same, 1.25 into
1.25
e to
ex.
the x. Same.
Yeah.
Now I am asking 10 to the power 5 into e to the power x. What is the differentiation?
Uh,
Same,
10
same,
raised
same.
to power 5 ex.
10 to the power 5 into e to the power x. Okay. So no need to write this.
Okay. Okay, sir.
Okay. So do you have any idea about the vectors?
Vector addition.
Huh. Anything about the vector addition, subtraction, multiplication, division? You know?
Yeah, somewhat.
Okay, no problem. I am just telling you. This is a point, and suppose from this point in this direction, a 3 Newton force is applied. This is F1. This is 3 Newton, and I am just asking whether you know or not. And a force of 4 Newton is applied in this direction at this point. This is F2. Suppose this is F2. So if I am saying calculate the resultant of both the forces, do you have
Yes.
any idea about this?
I think yeah, F net is equal to root of F1 plus F2 plus 2 F1 F2 cos theta.
Very good. F net is equal to under root F1 square plus F2 square plus 2 F1 F2 and the angle between them, cos of angle between them. So here F1 is 3 Newton, means 3 square. This will be 4 square. This will be 2 into 3 into 4 into cos into, what is the angle in between?
90.
90. And cos 90 is 0.
0.
You should, cos 90 is 0, sin 90 is 1.
Sin 90 is 1.
So learn this also. And one thing more, tan 45 is also 1.
Yeah, 1045.
So we can calculate this will become 0 whole term
Yes.
because this is
Yes.
0. So now 3 square, 4 square under root 3 3 is a 9, 4 4 is a 16, 9
5.
plus 16 is equal to
25.
25.
So
Fine.
yes, sir.
So I think now it's enough for today.
Okay, sir.
And if you have any doubt about the charge, about the current, about the vector, about the differentiation, so you can ask me.
Sir, I have one doubt. Uh,
Yeah,
you said in case of electron, when the electron is moving, the motion of the current will be in opposite direction, right?
yeah, of course.
So, sir, why is it in opposite direction?
Okay. Suppose you have taken the electron. Actually, we will study this in detail in our next topic.
Okay.
So listen first. I am telling you why it happens because in the conductor, initially, actually this thing we will study in our next topic, that is drift velocity. So in a conductor, what happens? Initially, the electrons inside the conductor are in a random motion. Means the electron here will be, some electrons are going like this, like this, like this, like this. Means this is the condition of a class before uh, before when there is no teacher in the class. So you can see all the students are moving from here to here. So you can think like that. And what happens? Now, when you have applied the electric field here, and this is the positive terminal. Electric field means you have applied the potential. Electric potential means some voltage.
Yes,
Connected
sir.
this wire like this wire with some
So
voltage.
when there is potential difference, only that time the current can flow, right?
Yeah. Means you have connected this battery with some, say, potential difference. Okay. And now what happens? We know that now what happens? Electric field will be generated. Electric field will be generated due to this. And we know that in an electric field, there is a, if there is a charge in an electric field, the force on this charge will be QE. Okay, charge will be
Yes, sir.
QE.
Yes.
Means what is happening here? This is the electron electric field is from positive to negative like this.
Yes, sir.
Electric field is from positive to negative, and electron will move in this direction. Electron will move in this direction, and the direction of current, the direction of current is in this direction due to this the direction of electric field. Okay,
Okay, sir. Got it.
and actually I will elaborate these things to you when we will study the topic drift velocity. Okay, all the all your doubts will be clear there.
Okay, sir. Sir, we don't require integration for this chapter.
Hmm, no, I don't think so. We
Okay.
will require the integration for the charges and fields, where we have to calculate, like we have to calculate the suppose this is a sheet and here we have to calculate the electric field. So in this case we will do that, like I am saying that here is a positively charged rod and I want to calculate the electric field here. Okay, so we know the electric field due to point charge kq by r square, but
Okay.
this is not a point charge, it's a finite charge. So for
Yes.
this we will take a small unit of this, okay, which will be at some distance x. And what is the use of integration here? Due to this element dx and having a charge dq, due to this element, one by one we will calculate the electric field, and that addition will convert into the integration. Integration means addition of the things. So
Addition of
in
small